Alright, today I'm going to be making a video on dilations. And just as a reminder, vertical dilations make the graph taller, and that's when you have an a value that's greater than 1, or an a value that is less than -1. And then horizontal dilations make the graph wider, which is when you have an a value that's between -1 and +1. Right? So before we actually dilate the graph, we're going to start with the equation y equals the absolute value of x plus 3 minus 2, where in this case our a value is 1, so the graph is not dilated at all. Our h value in this case is -3, which we get by taking the opposite of this number right here, and k is -2, which comes from right here, and h comma k, so -3 comma -2, gives us our vertex. So -3, -2, if I graph that, is right here. And to graph the rest of it, we're going to go ahead and make a table. And for this table, I'm going to put my vertex in the middle, so -3, -2 again. And then I'm going to choose 2 points to the left, so -4 and -5. And then I'm going to choose 2 points to the right, so -2 and -1. When I plug -5 in, -5 plus the square or plus 3 is -2, and the absolute value of -2 is +2, and 2 minus 2 is 0. Now I'll go ahead and do the -4 as well, so -4 plus 3 is -1, and the absolute value of -1 is +1, and 1 minus 2 is -1. And then because of the fact that absolute value graphs are symmetrical, we actually don't need to do the math for these two. We can just take these points and flip them around the vertex. So now I'll go ahead and plot the points -5, 0, and -4, -1, -2, -1, and -1, 0. And you can see that we get a nice V for our graph right here. So there's the original graph that's not dilated. And now we're going to go ahead and we're going to make it taller and do a vertical dilation, and we're going to do it by a scale of 2. So as you can see here, in order to dilate it by a scale factor of 2, I just change a to 2. And this is to vertically dilate it, because remember, for vertical dilations, a is greater than 1 or less than -1. And I'm going to go ahead and make a table for these values as well. Again, the vertex is still at -3, -2. And so I'll go 2 points to the left and 2 points to the right. When I plug the -5 in, I get -5 plus 3, which is -2, and the absolute value of that is +2, times 2 is 4, minus 2 is 2. And then if I do -4, it's -4 plus 3, gives me -1. The absolute value of -1 gives me 1. 1 times 2 is 2, minus 2 is 0. Then again, I can flip these points so that I end up having a symmetric shape. Alright, so now if I plot these, -5, +2 is right there. -4, 0 is right there. And -3, -2 is the vertex again, and -2, 0 is there, and -1, 2 is there. And so you can see on this one that we still have our V, but now the shape has gotten taller because each of the points have actually moved up. Okay. Now, if I wanted to take the original graph again that I have over here, the original equation, and dilate it horizontally by a scale factor of 2, I would actually change the a value to 1/2. So it would be y equals 1/2 times the absolute value of x plus 3 minus 2. And again, we're going to want to make a table. with the vertex as our middle point. And then we'll go ahead and we'll fill that in. I'll give you guys a little time to try filling this one in on your own, and then I'll show you what the answers are. Okay, if you still need more time, which I'm guessing you do, go ahead and pause the video so you can try to fill it in. Alright, and there are the answers that I came up with for this equation now. And so if I go ahead and graph them, -5, -1 is right here. Oops, no it's not. It is right here. And -4, -1.5 is right down here. And -3, 2 is right there. -2, -1/2. And -1, -1 is right there. And so you can see we now have a V that has gotten wider. So there are your two types of dilations. I hope this video helps. So thanks for watching, and feel free to contact me by email, Twitter, or at my website. And have a wonderful day.